All right, now that we've had some properties of logarithms down, now we're going to be going to solving logarithmic equations. So if we can get, so our goal is to be able to get a single logarithm. That's our goal. And then convert to exponential form. So this skill is kind of like applying both 5.1 and 5.2 so that we can actually solve logarithmic equations. And I want you to make sure you have in your notes or for your record just some practice with converting between exponential and logarithmic forms and vice versa. So this is kind of a template, so you can kind of see a general example and a specific example. So if we want to do log base 3 of 9, 3 to the second power is equal to 9. And that's how we can actually do that. And we can kind of go vice versa as well. So in 5.1, I already had you set like a logarithm equal to x. And I do that so that we can kind of convert between exponential and logarithmic form. And it also helps with solving. And some of your basic ones are actually just formally setting the logarithm equal to x. So if you write this as 3 to the x equals to 81, you could ask yourself 3 to what power equals to 81. And 3 times 3 is 9 times 9 again. So it's 3 to the third power. And actually, if you can do it in your head, a lot of people just do like x equals 3 and they be done with it. But if you're, maybe a little bit rusty with your mental math, you could just enter like 3 squared and see that that equals 9 and then go to 3 cubed. And you'll get the one that equals to 81. And then we could just say that x is equal to 3. Let's look at another example here. This one might even be easier because I write this as 9 to the second equals to x. And I know what 9 squared is, and that's just 81. And that's my final answer. This one is 256 to the 1/4. So you might want to use a calculator, or you could actually write this as the 4th root of 256. But if I do, 256 to the 1/4, that's equal to 4. Or you could just like use your delta math calculator as well. And then we're done. So a lot of these level 1 ones, they're pretty basic. So if you could just convert them into exponential form, you'll be golden and you'll get the answer that you need. Now let's actually go to the level of one where you have to use properties of logarithms. So I ask myself, is it going to be a product, a power, or a quotient property? And obviously I got a plus sign, so I'm going to kind of start with maybe thinking about the product here. And before I even do that, it's going to be the same base. So it's log base 2 of 5x plus log base 2 of 2 to the third And I'm just going to clean this up a little bit. I'm probably putting in like maybe 1 or 2 more steps than what's needed, but I just want everybody to see where this is coming from. So this is going to be log base 2 of 8. And now we're going to just use that product property. So this is log base 2 of 5x times 8. And this is log base 2 of 40x. So nothing wrong with just, taking your time a little bit. So I'm going to say that this is going to be 2 to the 0 equals to 40x. Two to the 0 is 1. And then x would just simply be equal to 1 over 40. So if you are using these properties right, you'll turn them into, kind of like multi-step equation level problems in Algebra 1 at the end of the day. Then we can do a quotient type of problem. This one does not have like the power rule, but this is kind of a giveaway that it's going to be quotient. So this is going to be log base 4 of 4x over 2 equals to 3. And 4x over 2 is just simply going to be 2x. And this is not a bad one to do because I'm going to have 4 cubed equals to 2x. So 4 cubed is just going to be 64. And lo and behold, I get 32 is equal to x. So overall, for these logarithmic equations, you want to use power, product, quotient rules, write as a single logarithm. And you want to convert to exponential form. And then after that, just solve for x. And that is how you solve a logarithmic equation.